Today in our final part of the unit, we're going to be talking about measurement. Measurement is a way to describe matter. It's a type of quantitative observation in which you're describing the matter that you're observing in a particular type of number. Like you might describe its mass, or its length, or its width, or its volume, that kind of stuff. To do that, you will use what we call the SI system, which is System International. It's just the French derivation, but it's called the International System of Units. And it's similar to the metric system, but a few little bits of differences. One thing it does share with the metric system is this kind of prefix system that it uses, which is really nice, built around the basic unit. So no need to measure no need to remember dozens of different types of units, dozens of different types of conversions, words that you can't remember. All that, all you really have to do is remember the basic unit and the prefixes. The prefixes are the same regardless of the unit, and the conversions are the same. All built around the number 10, which makes it really nice. No dealing with fractions. It's just a matter of moving the decimal point left or right, depending on how many places you're going to be moving from one unit to the next. So what do I mean by that? Let's say, for example, I wanted to convert 257.49 decameters to kilometers. And you can do this on test day in your head, or you can write these prefixes down. Remember in class we talked about kind of that memory device thing you can use where King Henry died by drinking chocolate milk. Okay, and the by is the basic unit, okay, which could be the gram, the liter, and so on and so forth, the meter, and all the system of prefixes builds around it. So if you're doing a conversion like this, which will be much more challenging in our system, because not only do you have to remember what the words are, you have to remember the conversion factor, and then you have to decide if you're multiplying or dividing. You don't have to do any of that in this system. Just start by figuring out where you're starting from, and then figure out where you're ending up. Okay, so in this case, we're starting at decameters right here, and we're going to kilometers here. So I'm going in that direction, so I'm going to be moving left, and then how many places will I be moving my decimal point? Once, twice, right? That's it. So I'm going to do the same on my actual problem here, once, twice. So my actual answer is 2.5749 kilometers. Notice the number is smaller because the kilometer is longer. And that's it. I could give you 20 problems. I mean, we had some practice problems. We did the lab activity. But that's basically it in a nutshell. Is just know where you're starting from and where you're going to, and count those number of places that you have to move to get there. Some of the things we might be measuring this year and some of your other science classes while you're here at McCarthy is you might be asked from time to time to measure mass, which is the amount of matter in an object. Mass is different than weight because it's not really affected by gravity, because you're talking about how much stuff is in something. The SI unit for mass is the kilogram. The basic unit is the gram. Kilogram would be like, if in our system, if we wanted to measure something in pounds. Gram would be a smaller amount. If you're wanting to measure something small, like in our system, we might use ounces. In the SI system, you might use grams at that point. Gram would be the mass of, like, say, a paper clip or maybe like a Tic Tac or something. Length, how long an object is, or the distance from one point to another, is measured in meters. So anytime you see the lowercase m, you know you're talking about length. No words to remember that you're not sure what they are or not. Kilometers will be analogous to like our miles. Centimeters will be like our inches. And then the millimeters are what makes up the centimeters, kind of like the 16th of an inch or a 32nd of an inch makes up an inch. The difference is the millimeter is much easier to work with because there's only 10 of them to make up a centimeter. So all you have to do converting from millimeters to centimeters is move the decimal point one place, left or right. When you're talking about the volume of an object, which is a three-dimensional measurement of an object, you're talking about the length, width, and height together. The SI unit would be the cubic centimeter for a solid. So if you see that unit, you know you're talking about the volume of something solid. If you see the L for the liter, you know you're talking about liquids, which is easy to remember because they both start with L. Liters will be to measure something larger, like, say, for example, if you have a pitcher of lemonade or something, you would use liters. Something smaller, like, say, a can of soda, you would use milliliters. Sometimes you might be asked, especially like in chemistry class, to measure the temperature of an object. The temperature, or the definition of temperature, actually the speed of the molecules in the substance. The faster the particles are moving, the higher the temperature. The slower they're moving, the lower the temperature. The metric system uses Celsius, which has a range from 0, which is the freezing point of water, and there's, of course, negative temperatures below that, and then to 100, which is the boiling point of water, and of course, you can go higher than that. In terms of the SI system, scientists use kelvins. The advantage of the Kelvin system over Celsius is there are no negative temperatures like in Celsius. 0 is the starting point for the Kelvin system, and 0 kelvins is the equivalent of negative 273 degrees Celsius, which is known as absolute zero. That is very, very low temperature. So that's where the starting point of kelvins would be, and then it would build up for there, so you have no negative temperature to have to deal with in your calculations. Okay. And so that closes out our first unit. When you're studying for these tests over the next few days, make sure you look over the presentation, look over the study guide, look over the readings of the sections which are matched up with the presentation also in the study guide. Make sure you look at any practice homework assignments. Make sure you look over any labs that we did, and also take advantage of the great practice in your textbook, the study area with the great interactive multiple choice questions, and also the flashcards so you can review your vocabulary.